Hi everyone. In this video we are going to discuss about effect of temperature on resistance. Why? Because in 11th standard you might have studied about the effect of heat and its properties. Okay, that means whenever I am heating there will be a considerable change in the properties of the other metals. Similarly here the particular resistance is getting heated, then the resistance value also will be changing with respect to the temperature. That's the thing we are going to discuss. Okay, but if there is a two effect based upon conductors and semiconductor insulator. If you take conductors, they will be in one group. Okay, that means in conductors when you are increasing the temperature, the resistance also will increase. But in the case of semiconductor and insulator, there will be a decrease in resistance when we are increasing the temperature. Why? Because initially in conductor, in the sense like there will be having large amount of free electron. So when the current is flowing, okay, the electrons will be moving in a proper path. Similarly protons also will be moving in a proper path. Okay, but when I am increasing the temperature, what will happen? Okay, when I am increasing the temperature, you know that like when you are boiling the water, the molecules start vibrating. Similarly the molecule inside this conductor will start vibrating. They will move up and down. Okay, so what is the thing is happening? The charge cannot be transferred from one electron to another electron, or one electron to another one proton to another proton properly. Okay, that's what we are telling, that the resistance increases. And also here the collision time considerably decreases. Okay, the collision time considerably decreases because you will be getting the rapid collision in the case of what? Increasing the temperature. But in the case of semiconductor insulator, initially they are not in a position to conduct because they may not have free electrons, so the electrons are tightly bounded together with the nucleus. So when I'm increasing the temperature, what will happen? They will be free to move from one place to another place, right? So they will start moving. So I can able to say that initially the resistance is very high. When we are increasing the temperature, there will be a possibility of movement of the electrons from one end to another end. That's what I'm telling, that whenever the particular temperature increases, the resistance will be decreases in the case of semiconductor and insulator. Here we are going to talk about the conductors, that is metals. Okay, so I can consider the resistance of a metallic conductor increases linearly with the rise in temperature, that we discussed. Why? So if you see the curve here, okay, temperature curve, what is happening? The resistance versus temperature curve I have drawn. When the particular temperature increases, the resistance also increases. Actually it is not starting from origin, it's starting in the somewhat high, that is above the resistance axis, right? Why? Because if you take R naught, because the at 0 degree Celsius also some of the metals will be having some kind of resistance. That's what we are starting from here. When the temperature increases, what will happen? For the T1 temperature we are getting resistance R1, for the T2 temperature we are getting resistance R2, like that it will be increasing linearly. Okay, so now that's what we are going to write. Consider a metallic conductor having resistance R0 at 0 degree Celsius, again R1 at T1 degree Celsius. Okay, then what about the increase in temperature? Final temperature minus initial temperature, I am writing R1 minus R0. Okay, so we are going to find out the proportionality, in what factor it depends. Okay, remember the R1 is minus R0, that is increase in temperature, depends upon the initial temperature. Okay, similarly the R1 minus R0 depends upon the increase in temperature delta T. Actually here it is increasing from 0, that's why T1 minus 0 will be getting T1 only, but it mainly depends on delta T, but I am writing what? Only T1. Okay, the next one, it depends upon the material, because copper may have some property, silver may have some property, iron may have property, they may not have the same properties. That's what we are going to write. It's nothing but R1 minus R0 is directly proportional to R0 into alpha T. To eliminate the proportionality, we are going to take the material into consideration. For that we are going to introduce one proportionality constant. So R1 minus R0 is equal to alpha into R0 into T1, where alpha is nothing but temperature coefficient of resistance, where alpha is nothing but temperature coefficient of resistance. So R1 is equal to R0 into 1 plus alpha T1. Okay, so when I'm taking this R0 this side, I can able to get R0 into 1 plus alpha T1. From here if I want to find out alpha, what I will get? R1 minus R0 divided by R0 into T1. Actually what is the definition for this temperature coefficient of resistance? Mean increase in resistance per ohm original resistance per degree rise in temperature. That means when I am increasing the temperature of a particular 1 degree Celsius, then how much the particular resistance is changing. That's what change in resistance divided by per ohm and per degree Celsius rise in temperature. The unit is nothing but, if you take I can able to say, okay, you can take, if the resistance of a conductor is R2 at T2 degree Celsius and R1 at T1 degree Celsius. Okay, can you able to understand from in the diagram? If you see, I'm going to start from here to here. Okay, that means T1 to T2. Initially we have studied from 0 to T1. Now we are going to study from what? T1 to T2. In the case of T1 to T2, what we will get? Okay, so if the resistance of the conductor is R2 at T2 degree Celsius, R1 at T1 degree Celsius, that means T1 is less than T2 we have to take. So R2 is equal to R1 into 1 plus alpha T2 minus T1. Okay, that means delta T. It's mainly what? Delta T. The general formula we have studied. From here, if you find R1, take it to this side, it will become R2 minus R1 divided by R1 into T2 minus T1. That is R1 into delta T. The unit, if you take, that's nothing but per Kelvin or per degree Celsius, because resistance unit will be cancelled, ohm and ohm will be cancelled out. You will be getting per Kelvin or per degree Celsius. That is equal to Kelvin inverse, or we can able to write it as degree Celsius inverse. And already we discussed, but semiconductor and insulators, the resistance will decrease with the increase in temperature. Okay, temperature will be decreases with respect to what? Increase in temperature in the case of what? Insulator and in semiconductors. Okay, and we have to take alpha is nothing but negative for that, because when the temperature decreases, R2 will be lesser than R1. So you will be getting the value in what? That is negative. So the particular conductor which conducting electricity, that is with negative conducting electricity with negative temperature coefficient, is known as thermistor. Okay, here the semiconductor and insulators having the alpha value is nothing but negative. Okay, based on this topic you will be getting most of the JEE, NEET and also board exam problems. So there are, well, read well. If you have any doubt, you can ask me in the comments. Thank you.